Have you ever wondered how a competitive robot is built? Using the engineering process to engineer a robot for a competitive robotics team, such as FRC or FIRST Robotics Competition team, guides a team through a repeatable journey. With the engineering process, a team needs to analyze the challenge, construct proof of concepts, transfer everything into CAD, manufacture machine parts, prototype, assemble, test, break, and iterate. Before building a robot, a team needs to analyze what goals they want to achieve. Some teams use a numbering system. P0 is an absolute must to be included. P1s are elements that would be great to have, and P2s are only if there's extra time. The team always comes back to these lists of priorities to keep them on track of where to focus time and energy. Next, a team works on proof of concepts. They might break into subgroups to focus on specific mechanisms. Often, at minimum, there are driving, intake, and scoring mechanisms. Each sub-team starts by asking, have we done this before? If yes, then they look at the design and figure out what aspects can be applied and what aspects won't work for the new robot. If no, then the team will start researching and borrowing ideas from their research. The proof of concepts are built out of inexpensive materials and are often powered by team members holding drills. The proof of concept sub-teams learn what they think will work best, communicate thoroughly with other sub-teams so that the robot will all work together, and then transition to computer-aided design, or CAD. CAD is critical so that the team can visualize how all the components will work together to complete the priorities decided upon. CAD regularly shows where parts interfere with one another before any materials and time have been used to build the robot. CAD programs allow teams to custom design robot parts and import pre-designed parts such as screws and bolts. Once the CAD is complete, it's time for manufacturing and machining. Lathes, mills, laser cutters, 3D printers, and CNCs are used on moderate level materials like hardboard to prototype the robot components. The CAD gives precise measurements so a team knows exactly where to cut, drill, and turn parts. A numbering system is used to identify all the parts so that in assembling the prototype, it is very clear what part is used where on the robot. The prototypes run off of wired-in motors instead of drills for more accurate testing. Once the prototype is tested, a team makes design adjustments and changes the CAD. Then the team remanufactures the final parts out of appropriate materials such as polycarbonate or sheet metal. While these steps take place, a software team is identifying what is needed to control the robot. An electrical team is designing their own custom components to wire the radios, computers, lights, pneumatics, and motors. Once the robot is constructed and wired, the software team starts running all the code to see what works and what doesn't. With the software testing comes two very important steps: breaking the robot and reiterating designs. Some parts aren't as durable as expected or have a different load than expected, and the robot breaks. A team will machine and manufacture spares of these parts for quick part exchanges. As the team watches the testing, they will try to reiterate their designs. While each robot has unique challenges, by using the engineering process, a team can have a predictable approach to producing an amazing robot.